In this example, we're going to use more than one of the rules. So let's take a look here. Studies show here that 48% of U.S. adults have cardiovascular disease. Suppose that those who develop cardiovascular disease, cholesterol is high in only 50% of the time. Also assume that in the general population of adults, about 10.6% have high cholesterol. And they give us some events here. So H is going to be an adult has heart disease. C is going to be that the adult has high cholesterol. Suppose one adult is selected at random. So we want to know, what is the probability that they have heart disease? So that is H. So 48% of adults have cardiovascular disease or heart disease. So that's the probability of H right there. So that's one of our given probabilities. What's the probability that they have high cholesterol? So probability of C. So in the general population, 10.6% have high cholesterol. So that's also a given. So that's 0.106. Given that they have cardiovascular disease, what's the probability of high cholesterol? So this is asking, what is the probability of C given H? Well, notice here, of those who have cardiovascular disease, 50% have high cholesterol. So this is 0.50. So that is a conditional probability. That's something that's given to us. Okay, so now they want to know, what is the probability that they have cardiovascular disease and high cholesterol? So we want to know what's probability of C and H. So we will use the multiplication rule here. So we know that the probability of C given H, so we want to combine that together with H. So this is going to be probability of H times the probability of C given H. So the given event matches the first event. So this is our A and B, and then this is B and A given B. So we're using that second version of the multiplication rule. And so probability of H, we had that up above, is 0.48 right here. And probability of C given H, 0.50. And if you multiply those, you get 0.24. So 24%. So 24% of people will have cardiovascular disease and high cholesterol. What's the probability that they have cardiovascular disease or high cholesterol? So that's asking, what is the probability of C or H? So that is the addition rule. So we're going to add the probability of C plus the probability of H. And then remember, we have to subtract out the overlap probability. So it's probability of C and H, which we just figured. So probability of C, that's our 0.106, plus probability of H, 0.48, and subtract out the overlap, C and H, which is right here, 0.24. And the calculator work there will give us 0.346. And let's see, part E, we want to know, are having cardiovascular disease and having high cholesterol independent? So independence, we can check more than one way, but one thing that we can do is we can look at the probability of C given H, and we can ask, is that equal to the probability of C? So in other words, does the given event make any difference? If these are equal, the given event does not make any difference and the events will be independent. If they're not equal, they're dependent. So C given H, that was 0.50 here. And then probability of C, that's our 0.106 there. And we can see that those are not equal. So are they independent? No, they are dependent. The probability changes given that another event has occurred. Are having cardiovascular disease and having high cholesterol mutually exclusive? So we want to see, is there any overlap? Well, we figured the overlap probability of C and H here, and it was 0.24. So probability of C and H, the overlap, equals 0.24. So that tells us that the overlap, C and H, is not equal to the empty set. So that means there is something in the overlap. So are they exclusive? No, there is overlap. So if they were exclusive, then the probability of the overlap would end up being 0, not 0.24. So, okay, so we got conditional probabilities in there. We've got multiplication rule, addition rule, independence, and mutually exclusive. So a lot going on in that example.